Hello, hi friends, my name is Nilesh. In this video, we are going to continue the 15 factor apps series. So let's get started. This is the fourth part of the series, and in the earlier videos, we looked at three different parts or six different attributes of the 15 factors. We started with part 1 talking about code bases, which talks about having a single code base for all the application related artifacts. Then we also talked about dependencies, which is to specify explicitly all the dependencies that an application has, to declare and isolate the dependencies. In part 2, we talked about config and backing services. Config is related to storing the environment specific information external to the application code, and backing services is about treating a backing service as an attached resource. The examples of backing services we looked at were messaging like Kafka or RabbitMQ. It could be caching like Redis, or it could be database services like a relational database or NoSQL database. In part 3, we looked at the separation of release and the run cycle, build, release, and run, to strictly separate the process of building an application and running it. And we also looked at the 4 phases, which is design, then build, release, and run. And the last thing we looked at was the processes. Processes talks about building an application as a executable process, a stateless process. In this video, we are going to talk about the next 2 attributes, the port binding and concurrency. So let's get started with looking at port binding. Port binding talks about identifying the application to the network using a port number and not a domain name. So what does this mean really? Let's try to understand how the applications were deployed before cloud native applications or before 12 factor applications became popular, or even for that matter, cloud became popular. So before this, we were having web servers, for example, and we used to deploy multiple applications into the process which was managed by a web server. So depending on the type of application, there were different web servers available. So let's say we were using PHP application, then the Apache web server is an ideal solution to deploy the application. If it's a Java application, then there are multiple choices like Tomcat, WebSphere, JBoss. There is Liberty Server. When it comes to .NET, we have the Internet Information Server or IIS. So applications were deployed onto these huge servers, and same server used to host multiple applications. And for the end users, then these were separated using, let's say, the port number or using a DNS. Now the problem here is this depended on having the web server with some runtime environment available. So a version of the web server, let's say IIS version 10 or IIS version 11. And if there were multiple applications deployed on the same instance of the server, then it would share the resources of that server, and whatever configuration was done at the server level was applicable to all the applications which were running on that web server. So if one application wanted to upgrade, let's say the version of IIS, it had an impact on each and every other application that was running. And sometimes managing the operational aspect of this became difficult. So when it comes to the cloud native application or 12 factor or 15 factor applications, these are built as a self-contained applications, and they do not depend on a requirement like having a runtime injection of a web server into the execution environment. Whatever is required for running the application, it is part of the self-contained package. So the web server also is part of the application itself. And we have examples like lightweight web servers like Jetty in case of Java and Crystal in case of .NET, which are used for this kind of applications which are self-contained. There is also one best practice which allows us to create one-to-one correlation between the application and the application server. So this means that there is only one process running, the web server or the embedded web server or lightweight web server, and there is only one application which is deployed onto that instance of the web server. This allows us to upgrade, or this allows us to scale that application independently of the other applications, because there are no other dependent applications or multiple applications in the same instance of the server. This is also in line with the rise of Docker containers. So if we look at best practices related to Docker, Docker also advocates that there should only be one process running as part of one container. Technically, it is possible to have multiple processes running, but again, the best practice is that one Docker container or one container should have only one process as a top level process running. So the last thing is the web application. It exports the HTTP as a service, and it binds to a specific port, and it listens to the request on those ports. So I have given a small example here in the diagram. Let's say my application or my website, www.handsonarchitect.com, is deployed in multiple environments. Like there is a production environment, staging, QA. Using this approach of port binding, I can have different ports assigned to this particular application in different environments. So in QA environment, I can be running on 8085 port. On staging, I can be running on 8081 port. And in production, I can be running on 8080 port. To highlight this, I would like to quickly switch to Visual Studio Code and show an example of what happens with Kubernetes. For example, Kubernetes has this port binding concept implemented natively as part of the services and deployments. So here is an example of a deployment manifest file which is related to RabbitMQ deployment, a producer deployment. I will not go through all the details of the manifest file and the metadata. I'll focus my attention on the ports section. So in the ports, when it comes to the deployment, we can define the container port. So we can expose a port from the container or within the container where the container would be listening for requests. So I also have an extension which gives a brief description about what this attribute means. So here we can see that container port is a number which varies from or which ranges from 0 to 65536, and it's the number of port to expose a pod's IP address. So once we expose this, then we can access this using the service. So service is again a Kubernetes object which provides an abstraction over the pods which are running. So pods can be scheduled on different nodes, and in order to have a stable endpoint where the other applications or the consumers of the application from outside the Kubernetes cluster can have a unified address or single address, we use a service. So the service manifest here declares again a port section, and we have a port which is exposed by the service. But the good thing is it can target a different port. And if you look at the description here, it says the number or name of the port to access the ports targeted by the service. So this particular service is used to expose that RabbitMQ producer deployment, and the producer deployment is exposing the port 80. If I want, in this case, I'm using the same 80 port to expose the service as well, but the service could very well be exposing port 8080, and internally it can map that port to 80, which is the container port. So what this allows us to do is we can have in the development environment, or when the application is built, the container image is built, that image exposes port 80, and then in the target deployment environment or the runtime environment, the service manifest, it can override that port, or it can map that port to a completely different port, and it can listen to port 8081 like I just showed earlier. Why this is important is as we move our applications to the cloud, there are some responsibilities which are shared by the cloud provider. Things like high availability, then the mapping of the network, mainly network related features, and things like fault tolerance, the scalability, these kind of things, they are handled by the cloud provider. So we might not have access to all the fine-grained things like we had in the on-prem environment, So it makes sense to make this configurable, and if you want to deploy this service to multiple places, then using this configurable approach, we can make it very easy to deploy the services or applications on cloud environment. So that is why exposing our service using a port binding makes it easier for the maintainability part, or to deploy the applications easily into cloud environments. The next factor which we talk about is concurrency. And for concurrency, I will take the same example that I took last time with regards to the stateless processes. So this is an example which I use in various of my demos. It's related to RabbitMQ producer and consumer, and this is deployed on Azure Kubernetes Service or AKS cluster. So what the concurrency related attribute says is that when it comes to scaling, concurrency mainly is required when we want to perform multiple operations within a short span of time, and we want to process, let's say, multiple things during the peak loads, for example, and we have a need to scale the application. If we are using the older approach of having a very huge web server and running multiple applications on that one server, when the need arises for scaling, it could be because of increased load or the current resources are not enough to handle the capacity or the growing needs of the application. In traditional applications, we usually do vertical scaling, which means adding more RAM, adding more CPU, and adding more physical resources to the server. When it comes to cloud environments, it makes sense to create smaller applications and microservices basically, and to make multiple copies of them. So instead of putting the effort or increasing the resources of one single server, we can scale the process, we can scale the instances of the application and distribute them across multiple machines. And we scale by using the process model, and we distribute the workload across multiple processes. The application has to be designed in such a way that it can handle the scaling needs by creating more instances of the application rather than increasing the resources of the server. So that's where we say prefer horizontal scaling over vertical scaling. And when it comes to cloud, again, cloud providers, they have a different mechanism using which we can use dynamic scaling methods. Azure, for example, has this virtual machine scale sets approach, VMSS, where we can define the range, for example, based on the number of incoming requests when the scale in and scale out has to happen. So cloud providers, they allow us to scale dynamically using either the traditional metrics like CPU, RAM, or number of requests, or it could be based on the telemetry. When it comes to Kubernetes, our favorite orchestrator for cloud native applications, there are things like horizontal pod autoscaler, which is built into the Kubernetes itself. And if we want some additional things, we also have things like Knative or KDA, which allows us to scale the Kubernetes deployments or Kubernetes applications based on external metrics like the number of messages in RabbitMQ. This particular example itself, which I use for the auto scaling capabilities using KDA, demonstrates that. So it could be like the number of messages in RabbitMQ, or it could be things like some Prometheus metrics like telemetry information. So using all this, we can scale. So the whole idea here is the application has to be designed in such a way that it can scale by creating multiple instances of the process, and not by adding more resources to the server or to the process itself. We also have to understand that when we do this, there is a challenge, because the application, the thought process of the developer has to change, and the application has to be designed in idempotent way as well. So if the same process is repeated multiple times, we should get the same output. So idempotency is this principle in software development which allows us to design a software system in such a way that even if we run the same process multiple times, we get the same output. And that is important because applications instances can come up and go down because of the dynamic scaling. So it's important that the application is able to cater to these needs. So, like I did last time, I would like to give some references. Whatever I spoke, most of it comes from the Beyond 12 Factor app report by Kevin Hoffman in the O'Reilly site. There is also a GitHub repo by Christopher Jude as part of the 15 Factor apps workshop. And similarly, there is a GitHub repo by Vikas Gupta, again related to the 15 Factor apps. So you can refer to this. So a quick summary of what we have done so far in this series. This is the fourth part of the 15 Factor apps, and we have covered 8 attributes so far. In the first video, or the first part of the series, we covered code-based dependencies. Second part, we covered config backing services. Third part, we covered build, release, and run, separation of these into different stages, and the stateless processes. And in this video, we covered the port binding, which is to expose the service via port binding, and concurrency, which helps in scaling out the process using the process model rather than vertical scaling. So with that, we come to the end of this video. I hope you found this useful. If you find the video useful, please hit the like button. If you would like to get notifications about new videos on my channel, please subscribe to the channel. Until next time, code with passion and thrive for excellence. Thank you once again for watching this video.